Hello dear students. So in this video we will be discussing about some important MCQs on concrete technology and RCC. This is our part B session and earlier I have uploaded part A. You can find it in the description box and also you can find the links of steel structure part A and part B in the description box. So before going to waste our time, let's discuss our first question. Is the flexural strength of M25 concrete? As we know that the flexural strength of M25 concrete or any grade of concrete can be determined by the empirical formula, that is your zero point 0.7 under root times of FCK. So we are having a FCK value is 25. So zero point 0.7 into under root of 25 is 3.5 MPa. So option B is correct, 3.5 MPa. So next question is, characteristic strength of M20 concrete is 20 MPa, and what is the number of cubes having 28 days compressive strength greater than 20 MPa out of 100 cubes made with concrete? As by definition we know the characteristic strength is that below which not more than 5% test results are expected to fall. So here 95% of cubes will have strength more than characteristic strength. Okay, so here option 95 is correct. Move on to the next question. What is the pH value of potable water as specified by IS code? So we know the as per Indian standard 456 2000 and on the clause 5.6 or 5.42, pH value of potable water should not be less than 6. Okay, so you have to remember that the pH value of potable water should not be less than 6. So move on to the next question. In case of two-way slab, the limiting deflection of the slab is. Okay, so we know the two-way slab may be checked for deflection control against the shorter span to effective depth ratios. And we are having a table like span to effective depth ratio depending upon the type of slab. Either it is simply supported or either it is continuous. So for simply supported slab, we are having two types of reinforcement like mild steel and like HYSD, that is Fe415. So for mild steel, we know the simply supported case, the mild steel span to depth ratio is 35, and for Fe415, the simply supported case, the span to depth ratio is 28. So, and also the for the continuous slab, we are having a span to depth ratio for mild steel is 40, and for Fe415, the continuous slab, we are having a mild effective depth ratio, span to effective depth ratio is 32. So you have to consider the shorter span. We are having a deflection control against shorter span. So you can remember the limiting deflection of the slab is only primarily a function of shorter span. Option B is correct here. So move on to the next question. From limiting deflection point of view, use of high strength steel used in RC beams is, as we know, the span to depth ratio of beam with different type of tension steel are obtained by multiplying the basic values of effective span to depth ratio with modification factor. So in that case, for high strength deformed bars, so we are having a high strength steel. So the effective span to depth ratio should be multiplied by zero point 0.8. Okay, for HYSD, we are having a span to depth ratio multiplied by zero point 0.8. So in that case, we have to increase our depth. So option C is correct here. We have to increase the depth. So option C is correct. Move on to the next question. In RCC beam, side face reinforcement is provided if depth exceeds. So you know the side face reinforcements is provided to when the wider cracks may develop up higher in the web portion. So to control that, we are having a side face reinforcement to be provided along the two faces of the beams with overall depth exceeding 750 mm. So option D is correct here. So the depth exceeds 750 mm. Yeah, we know in a deep beam, the flexural deep beam is a flexural member since tension reinforcements are generally provided close to the tension phase. in order to get maximum effective depth. So the portion of the web below the neutral axis will be in tension but without reinforcement. So we have to provide a side face reinforcement in that case in both the faces, and the overall depth exceeding 750 mm. So this is the reason that we have to provide side face reinforcement if our depth exceeds 750 mm. So option D is correct. This is usually asked in your examinations. So move on to the next question. The effective width BF of flange of a continuous T beam in a floor system is given by, and what is the formula? You know, BF is equal to L naught upon 6 plus BW plus 6DF. So here it is asked that what is L naught. So you know L naught is the distance between points of contraflexure, and which is also known as distance between points of zero moment in the beam. So option A, distance between points of contraflexure in a span, is correct. Okay. So usually it is generally asked what is L naught. Okay. So you have to keep in mind. So it is the distance between points of contraflexure and also known as the distance between points of zero moments in the beam. Okay, which may be assumed as zero point 0.7 times the effective span in case of continuous beams and frames. Okay, so you have to remember also in case of continuous beams and frames, the it is taken as zero point 0.7 times the effective span. Okay, so move on to the next question. What is the value of minimum reinforcement in case of FE415 in a slab? Okay, so minimum reinforcement in a slab is depend upon the type of reinforcement we are having. If we are having a Fe250, that is mild steel bar, then our minimum reinforcement value is 0.15%. And if we are having a Fe415, that is our case. So in that case, 0.12% is the minimum reinforcement. So the option B is correct for Fe415. Minimum reinforcement is 0.12%. Or for welded wire fabric, we are having a minimum reinforcement of 0.12% also. So option B is correct for Fe415 type of steel. So move on to the next question. Temperature and shrinkage steel is provided in reinforced concrete slab because as it occupies larger area, we are having a temperature and shrinkage reinforcement which is invariably provided at right angles to the main longitudinal reinforcement in a slab. So because the surface area of the slab is large, so temperature and shrinkage steel is provided as it occupies larger area. Okay, so move on to the next question is, a T-beam behaves as a rectangular beam of width equal to its flange if its neutral axis. So we know for T-beam having neutral axis within the flange area, our formula derived from rectangular beam can be used. So here the option C is correct. We are having a T-beam behaves as a rectangular beam. So in that case, our neutral axis lies within the flange portion. So you have to keep in mind the option C is correct. To move on to the next question, maximum area of reinforcement in compression and tension in RC beam. So we are having a maximum area in case of compression. You know that is the 4% of the gross area. So as per Indian standard 456 2000, the maximum area of compression reinforcement in beam shall not exceed 0.04 times P into overall depth D. Okay. So also for maximum area for tension reinforcement in beam shall not exceed 0.04 times B into overall depth D. Okay, so 4% for both the cases, that is for compression and for tension. Okay, so move on to the next question. A reinforced concrete slab is one is 75 thick. So the maximum size of reinforcing bar that can be used is, okay. So we are having a 75 thick reinforced slab, and the code limits the maximum diameter of reinforcing bars in slab to 1/8 of the total thickness of the slab. Okay, and the maximum spacing of such main bars to 3 times the effective depth or 300 whichever is less. So for a maximum size of reinforcing bar, we are having a thickness of 75 So 1/8 of 75 is 75 by 8 is 8 So The maximum size of reinforcing bar is 8 mm in this case. Okay, so you have to keep in mind the clause of Indian Standard 456/2000. So move on to the next question. In limit state method of design, the permissible bond stress in case of deformed bars is more than that in plain bars by 60%. So this is our important question. As for deformed bars, the bond stress shall be increased by 60%, we know, and for the values of plain bars in tension. Okay, and for the bars in compression, the values of bond stress for bars in tension shall be increased by 25%. So you have to keep in mind for plain bars for HYSD, these are the HYSD bar, our bond stress value is increased by 60%. And for compression, the values of bond stress shall be increased by 25%. Okay, so you have to keep in mind. Move on to the next question. Diagonal tension reinforcement is provided in a beam as as we know, the shear failure in beams causes due to the diagonal tension reinforcement, and to resist the shear, the provisions are as bent up bars, or you can say the vertical stirrups, or you can say the inclined stirrups. So here we are having a bent up bars in our option. So option B is correct. So your to resist your shear, we are using bent up bars or inclined stirrups or vertical stirrups. So diagonal tension reinforcement is provided in a beam to resist shear as bent up bars. Okay. So move on to the last question of this video. Lap length of reinforcement in compression shall not be less than. So again, from Indian standards, we know the lap length in compression shall not be less than 24 times the diameter of the bar. Okay. And for lap length in flexural tension, it shall be greater of 30 times the diameter of bar or the development length. Okay. So whichever is greater. For flexural tension, it is the 30 times the diameter of the bar or development length, whichever is greater. And the lap length in direct tension shall be greater of 2 times the development length or 30 times the diameter of the bar. Okay, so we know the LD is the denoted as development length. So in our question, we are having a lap length for compression. So our option B is correct. That is, it shall not be less than 24 times the diameter of the bar. And we know for flexural tension, it shall be greater of 30 times the diameter of the bar or development length. Okay. And for direct tension, it shall be greater of 2 times of the development length and or 30 times the diameter of the bar. Okay. So you have to keep in mind this clause of the Indian Standard 456/2000. Okay. So this is our last, and I hope it is clear to all. And if you like our channel, then please subscribe. And for more videos of civil engineering, and I will upload all the videos related to important subjects. And these are important questions which are generally asked and which are having a high weightage in every competitive exams. Okay, so please do like, share, and subscribe my channel, and stay tuned. Thank you so much.